feature encoding is one of the most important steps in data science. Now, what is feature encoding? Feature encoding is where you change the categorical data into numerical data for one reason. What is it? All for the compatibility of machine learning algorithms, because machine learning algorithms are trained to receive numerical data and not categorical data. And this is what feature encoding does. It transforms it also that machine learning algorithms can take this numerical data. So, to put it in short, it changes categorical data into numerical data, all for machine learning algorithms. There are many types of feature encoding, but the five most important types are ordinal encoding. Ordinal encoding is the first one, and it transforms categorical data into numerical data by assigning an integer for a category based on its rank. And this is very important for dealing with ordinal data, or in simple words, data with a categorical hierarchy. We come to the second one, which is label encoding. Label encoding also assigns integers, but it assigns integers for ordinal data that does not have a categorical hierarchy. In third, we have one-hot encoding. One-hot encoding is a bit similar to label encoding, but the difference is it does not assign integers, but it assigns binary values, 0 and 1. And the fourth one is binary encoding. Binary encoding is a combination of label encoding and one-hot encoding. Now, what makes binary coding better than one-hot encoding? It all comes down to memory. Binary encoding uses less memory compared to one-hot coding when dealing with data of high cardinality. The last one is target encoding. Target encoding assigns the mean of the particular target variable whenever that particular category comes. And also, here are some important notes. One-hot encoding is mainly used for dealing with nominal data, meaning data that does not have any kind of categorical hierarchy, or it's kind of random, as we can put it. So now, let us see how it works in real. So now, let us look. First, we invoke the CSV file, content encoding data. And after displaying it, we take three categories: hot, warm, and cold. And so we will look at the first type of encoding, which is ordinal encoding. And as you can see in the output below, hot is assigned 0, warm is assigned as 1, and cold is assigned 2. So as you can see, it goes like this: 0, 1, 2, 1, 2, 1, 2, 0, 2, 2, and so on. So as you can see, for each category, it assigned an integer and it is displayed like this. And now what we do is we concatenate this column and we put it under a BO2 and we concatenate it to our data set. Now we come to label encoding. In label encoding, you can see a new column called ORD2 with also having a set of integers 0, 1, and 2. But it is different to BO2. How? Well, take a look. You see 0 and 0 over here. So that's why you have it as 1. And you see blue and green over here. They have 1 over here. So that is why they have 2. So in the same way, since the column NOM underscore 0, it is ordinal, but doesn't have a big categorical hierarchy, these integers are assigned. Now we come to one-hot encoding. In one part encoding, let us assign this as two, red as 2, blue as 1 as 0, and green as 1. So as you can see below, red is the first, so it is 1. Blue takes the first and the second, so it is 1 1, and green is in the third, so it is 1. So in the same way, based on the presence of each color, the values 1 will be recorded if it holds true and 0 if it is false. So now we concatenate it to our data set. And also in the next step, what we simply do is instead of using zeros and ones, we're just using true and false. Now we come to binary encoding. And for here, we are using a completely new data set. And the column in question here is ORD2, in which you have these categories: high school, master's, diploma, bachelor's, and PhD. 5 categories. And since all of them are unique, we use the formula log underscore 2, log n2, or log 2n, and using that, we bring these columns ORD underscore 2 underscore 0, ORD underscore 2 underscore 1, and ORD underscore 2 underscore 2, and we assign the given values. And just like label encoding, it does not deal with ordinality, but it deals with categorical data with no ordinal relationship, and just like one hot coding, binary values are assigned. And last, we come to target encoding. So the column in question here is the city. So here we assign each city name as the target variable, and for them we are taking a mean value. So when you look at each city, they have a unique mean value, and whenever they repeat, so does the mean. For example, Delhi has a unique mean which repeats over here. Bangalore has a unique mean which doesn't repeat anywhere in the table, but you have Chennai which repeats over here, here, and here. So as you can see, wherever the target variable is there, you have its mean with it. And this is what target encoding is about. So now we have seen the encoding and its 5 types and how each of it works, and how feature encoding is a very fundamental step in feature engineering. Thank you.